Hi, my name is John Pettitt. I'm going to talk a little bit about the runtime. You've heard runtime mentioned a lot this morning. I am a senior staff software engineer at Google, which is a long-winded way of saying I write code. I've been working on AMP since 2015 outside of Google, and I joined Google October last year. And I think the most recent AMP extension I wrote was AMP Geo. And today I actually run the subscribe with Google team, so I'm working on the subscriptions product on it. So this is really everything you wanted to ask about the runtime but were afraid to ask. The first question is, what is runtime? It's a sort of interesting term. You can kind of think of it as the resource manager or the traffic cop, or the name really doesn't matter. Runtime's a convenient label. It does three main things. It helps conserve bandwidth, conserves CPU and memory, and it manages the privacy-preserving pre-render, which is a mouthful. To do that, we have to override the browser's natural behavior. So the runtime's going to do a bunch of things to do that. The four big things: scheduling, measuring, so it knows what's where on the page and when to instantiate it. Management of the life cycle of AMP elements after it's measured and scheduled. And then it provides a bunch of common services and plumbing to make it easy to do things, and to let us track things. I'm not going to talk much about those today, but they're worth looking into because you should really use our standard calls for mutating the DOM and things so that we know you've done it, so that we can then track it and remeasure things. So, moving along. So, what is it trying to do here? It really comes down to don't load it till you need it, and unload it when you don't. And to do that, we need to know where things are on the screen, or where things are on the page. And that actually turns out to be harder than it looks. And there's actually two measurement systems within AMP at the moment. There's the current one, resources, which is a naive measurement. It's sort of pixels from top left on the screen. And that's used to figure out where you are and whether you're coming into the viewport. It's kind of fragile. And when you start getting into complex things, particularly with horizontal scroll, it behaves in weird ways. So it's going away. The new one, layers, is currently an experiment. It's not live fully, but it's much smarter. It understands multi-layer stacks. It understands horizontal scrolling. For things like AMP stories and more complex carousel models, it becomes essential. You don't really need to worry about that specifically, other than to know that it is going to change. So what's this? Why do we have special elements in AMP? We want to override the browser's default behavior, because the browser sees an image, it's going to go and try and load the image file. We don't want it to do that, because the user's on a 3G phone connection and your image file is huge and it's going to slow everything down. Plus, we don't know how big the image is. So it'll come in and then it'll turn out to be a different size than you specified, or you didn't specify a size, the page will jump and it'll look lousy. So we create our own element. And the way we do that is with custom elements. Custom elements is this interesting feature of HTML that lets you create your own elements without spending a year arguing with the standards body about it. We use custom elements underneath, or a polyfill for them if the browser doesn't support it. But we really don't expose them to you as a developer. What you see is something called base custom element class. And that is something that AMP creates to manage the life cycle of AMP elements. And any AMP element you create is going to extend that. So you're going to see, AMP Geo extends base element. And there's a bunch of callbacks to manage that life cycle. I'm going to walk you through exactly what they all do. The first thing that happens when AMP sees an element on the page, so it comes along, none of your JavaScript's loaded, none of your extension JavaScript's loaded, and it sees, AMP iframe. It goes, what do I do with that? It creates an element stub. And that's just to stop everything breaking, basically. Element stub is a do nothing. And then we start going through the life cycle. And an element has really three main lifecycle areas. There are actually more subcycles, but the three main ones are it's not built, it's ready for layout, and layout complete. And they're kind of self-explanatory. I'll dive into all the callbacks. You can see on the right-hand side, there's a big list of callbacks. We'll go through those of what they all do and which ones you can ignore. So walking through the lifecycle, we start with not built. At that point, what's just happened is your element is attached to an element stub, and we're loading in your JavaScript. So your JavaScript is now going to come in and get attached and replace the element stub with whatever your element class is. And you're going to get the upgrade callback. And basically, you probably won't use this. It's really only for things that need to happen really, really, really early in the life cycle. You can't look at the rest of the DOM, and you may not have loaded the rest of the page. You can't guarantee that even your attributes are there or your child elements are there. Ads use it, AMP app banner uses it because they want to do things very early in the life cycle of the page. Most of you could just ignore it and let the default handler in base element just deal. And surprise, you get something that's not in the list of lifecycle elements. Mutated attributes. There's a callback if something mutates one of the attributes on your custom element. You'll start getting callbacks from us saying somebody changed, something else changed it. AMP bind tends to do that a lot. You can completely ignore it. In fact, that's what the base element class does until you get to a point where you care, like your element's actually been built and you're doing something. But the main thing to know is don't throw an error if you see this before your element is built, because you will see this before your element is built. There's another one, createdCallback. You won't use this. Yeah, it's a legacy thing. And in fact, nothing uses it in the current code base except the base element class, which does use it for its own thing. So it's in there because base element needs it. Otherwise, you could completely ignore it. I'm mentioning it because you'll see it in there and think, what is this thing he didn't talk about? OK, this one you might actually use. firstAttachedCallback, which really is misnamed. It used to mean you were attached to the DOM, but it doesn't anymore. It's sort of the first callback you're going to get that's useful. Some things use it. AMP image uses it to decide whether it's going to override the pre-rendering. Frankly, you could move that to the pre-render allowed callback. Again, it's not one that's used very much. You probably won't use it. You can probably ignore it. Aha, something useful. This one is pre-render allowed? And this is the privacy-preserving pre-render. And so what's happening here is we're asking your extension, is it OK to pre-render you? And what does that mean? It means, does your extension, is it going to do something that violates the user's privacy? Is it going to try and load a resource from something other than the AMP cache? Is it going to change something in local storage or do anything that might later indicate that the user had visited this page when it was in pre-render mode, when it was we were staging it before the user clicked on the link in a search result and the viewer pops it up, because we don't want to leak that information out, as Malta talked about this morning. So if you're a pre-render safe extension, you say true, you fall through into the next bits of code. If you're not pre-render safe, you're going to stop here. And you're going to stop here until the AMP page is actually on screen and comes out of pre-render mode, and then you'll start getting the next callback. And the next callback is the buildCallback, and this is actually a useful one. It's really the first taste of the DOM. Your attributes will be around, your children will be around. You can do basic mutations on things. This is a really great place to check that the user has actually put in, or the page author has put in all the parameters you need. This one is from AMP Hulu, and they're checking that the correct data attribute is there. User assert is a really useful thing for doing this. It will give them a nice, pretty error message. And don't rely on the validator to make sure that the user did the right thing. You can put it in a validator that yes, there was a required data, whatever, but if the AMP page gets loaded from somewhere other than the AMP cache, it won't have gone through the validator. So you really don't want your extension to crash or throw an error because something's missing. So user assert, buildCallback's the right place to check your configurations and let the user know if they screwed it up. Don't do anything CPU intensive, GPU intensive here. You still can't do any network activity here. It's in the critical path to rendering the page, so you really want to keep it light and only change what you really need to. Starting to get into the ready for layout phase, and there's a couple of calls that happen very early just to check. One is create placeholder. So if you need to make a placeholder for your element because you're going to be loading something on the network later, this is where you do it. And AMP image does some interesting things with its cool blurred placeholder thing that we just added. And then the other one's the pre-connect callback. And what's happening here is you're giving us a bunch of URLs that you say, I'm going to want to connect to this URL at some point. We're ignoring the path part of it and pre-connecting to the origin. And if the browser supports pre-connects, that all just happens silently. If the browser doesn't support pre-connects, you'll see a bunch of console error messages with 404s, and it's a long string that basically says, you can safely ignore this. And that's basically us opening a request to that site to get the TLS handshake and the DNS lookups and all of that out of the way early and pre-warm everything. Even if you're pre-render safe here, you can make network calls to the AMP cache, but nothing else. You can't do them further on. The other one you're going to get here is render outside viewport. And I talked about the lazy loading. AMP tries to figure out what's on the screen and what isn't and when to load it. And render outside viewport is your hint to AMP about how close do I want to be to the screen before you put me on the screen. So you're going to return a number, which is viewports. And it's a sort of a Goldilocks thing, because you don't want to render too far away from the viewport because you're consuming resources the user might never need. But you don't want to wait till you're too close because you won't be ready when the user actually scrolls. So you have to sort of make a guess here. And it's sort of non-intuitive because lightweight things can actually load further away, but heavy things, you really want to wait until you're really sure the user wants to use it, and iframes are really heavy. So you'd think, my video iframe is going to take a while to load, I really want to have a lot of viewport space on that. No. Yeah, you might in terms of getting it on the screen, but the flip side of that is it's going to consume a lot of resources, so we're probably going to have you put in a lower number here. This is something that will get talked about in design review when your component comes up in the design review process. So, woohoo, we are about to get laid out. And this is like the main lifecycle callback. This will happen when you've actually got within that viewport distance of the user. And it's saying, okay, we're actually going to put something on the screen, and you can make network requests now, which is really great, unless you're in pre-render mode, in which case you can only make them to the CDN. Well, this is where you actually get to lay out your element. You can build an iframe if you need to. You can do things with the DOM. It reserves a promise when you're loaded. This is where the kind of the more heavier stuff in your code can run. Nothing in AMP should be heavy, but yeah, the heavier things. And it returns a promise. You may never get here. If your element is at the bottom of the page and the user never scrolls to it, you may never get here. So it's worth keeping that in mind. You may also end up here twice, and we'll talk about that in a minute. Here's an example. This one's from AMP image. And there's a few things I want to highlight in this. One is there's the dev assert at the top there, where it's asserting that this image exists. Dev asserts are your this should never happen catches. They come with an implicit comment of this should never happen. It's the way you catch against things getting called from places you didn't expect them to. It's useful to put them in, particularly if it's going to break badly for, if something's missing. And the runtime will deal with those. We also created some listeners here. And I want to point out that we're not using the add event listener. You see they're using listen image. That's a helper that the runtime is providing. A lot of these helpers exist because AMP runs in weird places. When you're running in layers, when you're attaching something from a PWA, when you're running in a pre-render mode and so on, the helpers let us keep an idea of what's going on. Sometimes the runtime is going to note that you've done something with a helper, particularly if it's changing the DOM, in order to make sure that we can remeasure anything we need to remeasure. And then it returns a promise to say, hey, I'm going to go load the image, I'll resolve when I'm done. So now we're out, we're on the screen. Woohoo. A couple of other callbacks that will happen here. Pre-connect callback comes back again. This is a warming thing. In this case, it's for, I know I'm going to need this connection in a bit. It's a little different from the first pre-connect callback in that it'll actually keep the connections open longer. The first time you get pre-connect callback, it's 10 seconds. This will keep them open for 180 seconds. Again, it's just about getting the TLS handshakes done and getting the DNS warmed and connecting to whatever you need to connect to. And it's smart enough that if it's already pre-warmed a connection for something, it won't do it again. And it's fairly clever. First layout completed. You could probably almost call this please hide the placeholder callback because that's pretty much what everybody uses it for. In fact, the default action in the base element class is to hide the default placeholder if it exists. You can do other things in it. With all of these callbacks, by the way, grepping the /extensions directory for the callback names will bring up everybody that's using them, and you can get a sense of what people are using them for and see them in the wild. And then is relayout needed is the last one in the layout complete phase. This callback is really saying to you, if I resize your element, do you need to know about it? Ideally, in a perfect world, we'd love people to just use the AMP layout system, layout, intrinsic, layout, responsive, whatever, because we put in some CSS-driven placeholders in there so that when the user resizes the page or goes from landscape to portrait or whatever, it all just sort of works. And the browser does it, resizes your thing, and it's just great. And you don't need to write code. If you need to run code when you resize, and I guess the canonical example of this might be adds, where you might actually want to load a different sized add element into the space because it got bigger and you could put a bigger element in there and make more money out of it, then this is where you get called back. And so you get a callback and you say, is relayout needed? You could say yes, and then if the page relays out, you'll get your layout callback again. Hence the comment about you may end up at the layout callback twice. Another not a lifecycle callback, but a very useful one. It's called the viewport callback. It's really telling you you're on the screen, kinda. The kinda is that when you're in pre-render mode, it really does mean you're on the screen. So if you're a pre-render safe element, it's telling you, yes, I'm in the viewport, I am going to be seen. When you're outside pre-render mode, the window is a little bit bigger. There's like a 25% buffer around the viewport. And it's there to let you turn off expensive things. Pause the video, turn off that animated GIF, stop doing things that make no sense to happen outside the viewport. So it's AMP just telling you, you came into the viewport, you went out of the viewport. It's a really handy feature, and it actually makes quite a difference to the performance of things if you can turn off what you don't need. And then the last lifecycle callback is the unlayoutCallback. AMP pages could sort of go back into a pseudo pre-render state. It's not really the pre-render state, But if they're like in the carousel on a search results page and you swipe to the next story, you might find that the AMP page is still there. It's still an iframe, but it's been unlaid out. So this is where we want you to kill everything that is heavyweight. We want to stop any network activity. Iframes must die. Iframes are really expensive, particularly on Android. And so particularly on a low-end Android device, leaving iframes hanging around when you don't need them is a very bad thing for user performance. They chew up ridiculous amounts of memory and generally make things slow. So unlayoutCallback, destroy all the things. And then you might, if the user swipes back again, get a layoutCallback again to come back. And you can sort of bounce around this circle. So to recap the phases: not built, ready for layout, layout complete. Not laid out is the short-lived. There's some sort of intermediate phases that you really probably won't see. There's a not laid out, there's a short-lived thing that is just before ready for layout. There's layout scheduled, which really means we've called your build callback, but you haven't returned the promise to say you've been built yet. And there's layout failed, because if something broke, then you'll go into a layout failed state. You don't really need to worry about those. They're sort of internal states. And a little word about how we prioritize this. Things happen. Upgrade to not built is very greedy. Happens immediately. It's critical path to rendering the page. We're going to go through and we're going to run that for every AMP element on the page. So you want that to be very lightweight. Build callback also happens eagerly for the stuff that's in the viewport and subject to pre-render restrictions. There's actually a cap of about 20 in pre-render mode. We won't call a build cap on more than 20 elements, even if they're pre-render safe, just to stop chewing up too much resource. But that's also eagerly called, so you really want to make sure that you're not doing anything heavy in there. And then from layout callback to layout complete, this is kind of special because this is priority based, and this is how close am I to the viewport is probably the main priority stuff. There's some other stuff inside that you don't really need to worry about. Naively assume it's just how close I am to the viewport, and you won't be wrong most of the time. And that's really what decides who gets called next and how. So it really comes down to custom elements, where we hide that behind AMP's base element class. Elements progress very quickly through to ready to layout, and then they hang around there until they're close enough to the viewport to actually appear. And it's the distance to the viewport that is going to decide what it is that is going to get built. And that's the talk, and we're back on time.